I spent a bunch of time watching different tutorials on adding drifting to a car in Unreal. After that experience, I wanted to create a tutorial that shows you the entire process from scratch. We will go through each step so that you understand all the pieces. Let's get into it. Let's start by creating the tire skid texture. It doesn't have to be super fancy, so we'll just make it in MS Paint. It also doesn't have to be very high resolution, so we're going to go into properties and set it to 512 by 512 pixels. You don't have to make it this small, it's just a personal preference. For the skid mark, I'm going to draw a black circle and fill it in. I'm then going to use a spray paint tool to soften the edges. Looks good to me. Now we want to save the image. I'm going to name it Tire Skid. Next, we have to replace our PNG's white background with a transparent background. There are a ton of tools online to do this, but I like XNViewMP. I put a link to download XNViewMP in the description. Once you download it, open it and navigate to your tire skid file. Select it and click on the Batch Convert button. This will show a pop-up. Click on the Actions tab, Add Action, Transform, Transparent Color. Select white as the color we are converting to transparent. It should be set to that by default. You can preview the output, and if it looks okay, click Convert. Now we have one with a white background and one with a transparent background. Awesome. Let's hop into Unreal. In Unreal, let's start by making a new folder called Tire Skid. Inside the Tire Skid folder, let's import our image. Once it's imported, open it up to make sure it's okay. We're going to create a new material using the image. Right-click the context window, select New Material, and let's name it M_Tire Skid. Inside our new material, right-click and create a texture sample node. In the texture sample node settings, we can set our texture to the imported tire skid image. Let's hook up the RGB output node to the base color, and then let's connect the alpha output node to opacity. We then need to go into the material settings and change the blend mode to translucent. Sweet, now we can see our texture. Out of habit, I'm going to add a texture coordinate node, although it's not necessary. I'm also going to set the shading model to unlit. We don't really need to calculate shading. Okay, we have our material. Now we need a way to apply it to the ground. We're going to use Unreal's built-in particle system, Niagara. To do that, right-click the content window and select Niagara System. Unreal will show a pop-up of many starting templates. Let's select Fountain as our starting system. Then let's rename the Niagara system to NS_Tire Skid. Open up your new Niagara system and you will see a fountain already being previewed. It looks pretty cool, but we're going to modify it so that instead of spraying particles up, we're going to be spraying our tire skid material on the ground. To start, let's click on the white particle icon at the top of the fountain node and set it to our tire skid material. Next, let's turn off Add Velocity, Gravity Force, and Drag. Now let's go into particle spawn settings and set lifetime mode min-max to 5 seconds and sprite size to 40. So now we have all the particle sprites spawning at the bottom of the fountain without moving. Let's turn off shape location in particle spawn and then click the green plus button. Let's add sprite facing and alignment. All the sprites are spawning at the bottom but facing different directions. We want them all to face upwards. So in the sprite facing and alignment settings, set the sprite facing to 0, 0, 1. Now all the sprites are facing up. Let's see how this looks. Drag a copy of your Niagara system into the level. If you move it around, you see it drawing a line behind it. That is because we are spawning 90 tire skid particles a second. Each particle keeps the location it was spawned at. We also set each particle to have a lifetime of 5 seconds. That is why the oldest particles at the end of the streak are disappearing. So we have our tire skid being generated. Now we just need to associate it with our vehicle. Open up your vehicle's blueprint, and in the viewport we're going to click Add Component and add a Niagara Particle System component. Make sure it is a child of the vehicle mesh component so that it moves when the vehicle moves. Let's rename it to BL_tire skid. Select the Niagara component, and we're going to set the Niagara system asset to NS_tire skid fountain. We are then going to move it so it's at the bottom of the left wheel. Then let's duplicate the component by pressing Ctrl-C and Ctrl-V and move the duplicated skid to the other back tire. Let's rename it BR_tire skid. Now let's compile and drive our car around. As you can see, we now have skid marks drawing behind us. If we drive really fast, the skid marks get choppy, so you might have to adjust your fountain spawn rate, or make the particles larger and make their edges blurrier so that they mix together better. Next step, let's make the drifting lines only appear when you are actually drifting. To do that, let's add a controller input for drifting. So inside Vehicle Template, Input, Actions, right-click, go to Input and select New Action. Let's name our new action IA for Input Action _drift. Open up IA Drift. The value you type will remain Boolean because drifting is either on or off, and then let's add two triggers, pressed and released. Now we need to add our new input action to our input mapping. Again, if you're using Chaos Vehicle Template, go to Vehicle Template, Input, IMC_default. In here, let's click the plus icon at the top to add a mapping. Scroll down to it and set it to IA_drift. Here, we also set what keys map to our action. I'm going to set the input keys to left shoulder button and the Q key. Now, if we hop back to our vehicle's blueprint, we can right-click and there will be an enhanced input action IA drift. Let's select that node, and then we can perform actions based on when we press our drift buttons. To confirm everything is working, let's print a string when the input is started, ongoing, and completed. Cool, so we can see that started is called once when the button is pressed, ongoing is called each tick after that, and then completed is called at the end. Since we know it is working, let's activate the Niagara systems when input is started and deactivate them when the input stops. Let's also click on the Niagara systems in the viewport and set their default auto activation to off. Check it out. We can now start the drifting skids whenever we want. It looks like we're drifting, but the car's handling isn't changing any. In the next section, let's set up the actual drifting behavior. There is an overwhelming number of settings on the vehicle movement component. Let's just focus on what matters to us. First off, let's go to our vehicle's movement component and confirm that mechanical sim is enabled. With this setting, we are saying we want to use physics simulation and the physics of the wheels turning to move our car. That's all we're going to check in the vehicle blueprint. Let's now open up one of our vehicle's chaos wheel blueprints. Scroll down and you'll find the lateral slip graph. This graph is key to controlling drifting. So what is lateral slip? It's a fancy term for a simple idea. Lateral slip is when a wheel is sliding side to side instead of rolling forward. Let's look at an example. Here we have a car laterally slipping because its wheels are pointed up, but the car is sliding to the right. We describe lateral slip with the slip angle. The slip angle is the angle between the direction the wheel is pointed and the direction the wheel is actually moving. In this example, the slip angle is 90 degrees because the wheel is facing up and the car is sliding directly to the right. Here's another example where the slip angle is closer to 45 degrees. And just to be thorough, here's a third example where the slip angle is closer to 25 degrees. Now we know what lateral slip is and what the lateral slip angle means. So what does the lateral slip graph do? Well, it describes how much grip resistance the wheel has to sliding at different slip angles. The x-axis is the slip angle. The y-axis is the amount of grip resistance the wheel has to slipping. The higher the value, the more resistant the wheel is to slipping. In real life, the slip resistance increases as the slip angle increases until we reach a peak, and then the slip resistance actually starts to go down. When drifting in real life, we drift because we overpower the slip resistance. We can do this by increasing the amount of slip force or turning the wheel so that the slip angle changes to one that has less slip resistance. So back to our chaos wheel slip graph. Now that we know what we are making, let's create our own. Click the Create External Curve button and it will create a new curve object. I'm going to name it Simple Slip Curve. Open up the curve, and we're going to add a point to the curve by right-clicking and selecting Add Key. Select the point, and in the top left corner, set the X value to 0 for a 0-degree slip angle and 1000 for the slip resistance. Let's right-click the graph again and add a second point. We will set the X value to 90 for 90 degrees and the Y value to 1000 for 1000 slip resistance. I always get confused on this, but if you go to View, Absolute View Mode, it should fit the graph to display both points. Our graph is very simple and unrealistic to life. We are saying that no matter the slip angle, resistance to slipping will be 1000. For our arcade driving game, that's okay. Let's now go into the other wheel our car uses and apply the curve to it as well. Let's compile and confirm our car is not acting odd. Okay, next step, we want to modify the curved graph so that it resists slipping less when we are pressing the drift button. To do that, open your vehicle's blueprint and go to the IA drift event action we created earlier. Right-click and search for Get Chaos Wheeled Vehicle Movement Component. Notice how I pulled off the vehicle movement component? That won't work. We want the child version of the component. Off the Components node, search for Set Wheel Slip Graph Multiplier. This node takes in a wheel index and multiplier value. The index corresponds to the wheels array in our movement component. The multiplier is applied to the value we read from the slip graph. In our case, our slip graph always returns 1000. So if we set the multiplier to 0.1, then when drifting is on, our slip graph will always return 100. Let's go ahead and apply this to all of our wheel indexes. When we let go of the drift button, we want to scale the curve back up to its normal value, so we'll set the multiplier to 1. Let's see the results. Awesome, now we're drifting. We are seeing the drift and actually controlling it differently. We haven't really taken advantage of the slip graph. Our example is incredibly simple. I encourage you to tinker around with it and see how you can make drifting feel more or less controllable as the player tries to steer while drifting. If you like this tutorial and want to see more, please consider subscribing. I look forward to seeing what you create. Thanks. Bye.